People in South Florida have started their spring cleaning a little early this year by rounding up green iguanas in their gardens and on sidewalks and streets.
In the humid sprawl of South Florida's canal networks, something unusual is unfolding beneath the surface of an already familiar invasion. Green iguanas, once considered unstoppable, multiplying across neighborhoods, seawalls, and suburban gardens in the hundreds of thousands, are suddenly thinning out. Camera traps, field surveys, and long-term monitoring sites across regions like Miami-Dade County are recording unexpected declines in localized populations. Millions of iguanas are disappearing in Florida. The real predator isn't what you think. Let's start from the very beginning. Origins and rise of the green iguana in Florida. It all started in the late 1960s, when shipments of exotic reptiles started arriving in Florida through a booming pet trade that few regulations truly controlled. Among them was the green iguana, a species native to the tropical forests of Central and South America, stretching from southern Mexico to Brazil. Juveniles, small and manageable, were sold across the United States. But Florida, especially Miami, became a focal point. By the early 1970s, reports began surfacing of escaped or deliberately released iguanas in suburban neighborhoods. At the time, these sightings were mere curiosities. No one tracking wildlife in Miami-Dade County could have predicted that these scattered releases would seed one of the most successful reptile invasions in North America. Florida's subtropical climate mirrored the iguana's native environment with near precision. Average winter temperatures in South Florida rarely drop below 15 degrees Celsius, a threshold well within the species' tolerance. Unlike many invasive species that struggle to establish, green iguanas required no adaptation period. They fed on readily available ornamental plants, thrived in canal systems, and found nesting grounds in sandy soils along urban developments. By the late 1980s, small breeding populations had stabilized. Expansion accelerated through the 1990s. Surveys and anecdotal reports documented a steady spread northward into Broward County and Palm Beach County, with additional populations emerging in the Florida Keys. This wasn't random dispersal. Iguanas followed canals, levees, and roadways, which acted as ecological highways. These corridors provided basking sites, protection from predators, and easy movement between habitats. By the early 2000s, wildlife agencies began recognizing a pattern. Wherever there was water management infrastructure, there were iguanas. What made their rise particularly effective was their seamless integration into urban ecosystems. Unlike native reptiles that depend on specific habitats, green iguanas exploited human environments with remarkable efficiency. Seawalls became basking platforms. Residential gardens turned into feeding grounds rich in hibiscus, bougainvillea, and other flowering plants. Canal banks provided both shelter and nesting sites, with females burrowing tunnels up to 2 meters long. Studies from the University of Florida's IFAS extension documented densities exceeding 100 individuals per hectare in some urban zones. These numbers are rarely seen in their native range. Soon, the scale of the problem forced a policy response: population explosion and ecological footprint. By the early 2000s, what had once been scattered sightings of green iguanas in South Florida had transformed into a measurable ecological force. Field biologists working across Miami-Dade County began reporting population densities that no longer fit traditional invasive species models. Surveys from the University of Florida's IFAS extension and wildlife monitoring summaries from the Florida Fish and Wildlife Conservation Commission converged on a troubling range: hundreds of thousands of individuals statewide, with credible estimates pushing beyond 1 million in peak conditions. It was no longer a localized invasion. It had become a distributed biological network embedded across an entire region. In certain microhabitats, especially along canal systems and reclaimed wetlands, the density reached levels that surprised even seasoned herpetologists. Research transects in urban edge environments documented more than 100 iguanas per hectare under optimal conditions, an intensity more typical of small insect colonies than large vertebrates. These weren't isolated clusters either. They formed continuous chains along waterways stretching through Broward County and into parts of Palm Beach County, effectively turning engineered water infrastructure into a living corridor. The canals designed for flood control had become movement highways for a reptile population that required no seasonal migration cues, only sunlight, vegetation, and vertical structure for basking. Then there's reproductive efficiency.
I was digging in my gravel and I dug up this nest of undoubtedly iguana eggs.
A single female green iguana produces between 20 and 70 eggs per clutch, with many individuals laying once or twice annually in Florida's extended warm season. That means a conservative reproductive output of 40 to 140 potential offspring per female each year, before accounting for survival. Even with high juvenile mortality, often exceeding 70 to 80% in natural conditions, the reproductive surplus remains enormous. In ecological terms, the system is not just self-sustaining. It is aggressively additive, layering new generations faster than attrition can remove them. This reproductive pressure translates directly into structural damage across the landscape. One of the most persistent impacts is burrowing behavior. Iguanas excavate tunnels in canal banks, seawalls, and levees, sometimes extending several feet underground. Engineering reports from South Florida municipalities have linked this activity to destabilization events requiring repeated repairs, with cumulative costs reaching hundreds of thousands of dollars annually in some counties. The damage is not always immediate or visible. Instead, it accumulates silently. Voids form beneath concrete, soil collapses after heavy rainfall, and water systems get slowly compromised by repeated excavation cycles. Vegetation loss adds another layer to the footprint. Iguanas are primarily herbivorous and highly opportunistic feeders. In residential areas, they consume ornamental plants such as hibiscus, bougainvillea, and citrus seedlings, while in natural zones, they feed on native shrubs and coastal vegetation. Over time, this selective pressure alters plant community composition. In some monitored plots, native regeneration rates decline as preferred plant species are repeatedly stripped before reaching maturity. The effect is not dramatic in a single season, but over the years it reshapes the botanical structure of entire corridors, particularly in fragmented urban ecosystems. Public health considerations make matters more complicated. Green iguanas are known carriers of salmonella, with studies showing contamination present in both wild and captive populations. While transmission to humans is relatively rare, the risk increases in urban environments where iguanas frequently traverse patios, docks, and swimming pool areas. In South Florida neighborhoods, particularly in densely populated parts of Broward County, public health advisories have occasionally emphasized hygiene precautions after direct or indirect contact. The issue is not widespread disease outbreaks, but persistent low-level exposure in environments where humans and iguanas increasingly overlap. Ecologically, the most significant consequence is competition. Green iguanas occupy a niche that overlaps with native herbivores, particularly in terms of plant consumption and basking habitat. While they do not directly eliminate native species, they impose chronic resource pressure. In simplified urban ecosystems, where biodiversity is already reduced, this competition becomes amplified. Native species, such as turtles, birds, and smaller reptiles, must share limited basking sites along canal edges. Vegetation consumption also reduces available food resources across trophic levels. Soil stability is another underappreciated dimension of their impact. Burrowing alters compaction and water flow in riparian systems. Over time, this changes how water moves through canal banks and coastal edges, increasing erosion susceptibility during storms. In a region already vulnerable to sea level rise and extreme weather events, these incremental disruptions matter. Engineers studying infrastructure resilience have noted that iguana activity rarely causes catastrophic failure on its own, but it weakens systems already under environmental stress, accelerating breakdown when combined with flooding or storm surges. By the late 2010s, wildlife managers began describing the situation in increasingly mechanical terms. The population was no longer viewed as a species spread. It was a structural load on the ecosystem. Even removal programs, expanded after policy changes by the Florida Fish and Wildlife Conservation Commission in 2019, function more like pressure relief valves than control mechanisms. Tens of thousands of iguanas are removed annually. Yet population estimates remain in the hundreds of thousands to over 1 million. To make matters more complicated, there is no single epicenter, no central population core that can be targeted for elimination. Instead, iguanas exist as thousands of interconnected subpopulations. Each is adapted to local conditions. This fragmentation creates resilience. Human intervention and its limitations. By 2019, the Florida Fish and Wildlife Conservation Commission formally removed green iguanas from its protected species list, effectively changing their legal status from wildlife to invasive nuisance on private land. That decision meant residents could now kill iguanas year-round without a permit, a policy aimed at accelerating population control across heavily affected regions like Miami-Dade County and surrounding urban corridors. The policy quickly triggered an expansion of a niche but rapidly growing industry. Professional iguana removal services multiplied across South Florida, offering targeted culling for residential neighborhoods, golf courses, and waterfront properties. The cost per removal ranged between $50 and $150 per animal, depending on property access, density, and method used. In high-density zones along canals and suburban developments in Broward County, contractors reported removing hundreds of iguanas in single coordinated efforts. Across the state, cumulative removals reached tens of thousands annually, creating the impression of active control. But behind the numbers, a structural limitation was already clear. Removal efforts were geographically fragmented, driven largely by private demand rather than ecological strategy. One neighborhood might aggressively remove iguanas, while an adjacent area did nothing. This patchwork approach created constant reinvasion pressure. Iguanas, highly mobile and adapted to linear infrastructure like canals and drainage systems, simply moved across untreated zones. In effect, control efforts resembled pushing water uphill in disconnected buckets. Localized success, but no system-wide reduction. Reproductive biology compounded the problem. Female green iguanas produce between 20 and 70 eggs per clutch, and in Florida's warm climate, many are capable of laying 1 to 2 clutches per year. Even under high mortality conditions, this reproductive output generates rapid rebound dynamics.
Florida's iguana invasion is heating up. The big lizards can be found everywhere, from canals and in your backyard.
Yeah, and state officials say the population has grown out of control and they're stepping up efforts to get rid of them.
Wildlife biologists often describe it in population modeling terms. Removal reduces current density, but reproduction rapidly restores it to equilibrium. In practice, this means that even intensive culling campaigns can be offset within a single breeding cycle, particularly in warm years. Another constraint emerges from what ecologists call source-sink dynamics. Heavily managed urban areas act as temporary sinks, where iguanas are removed faster than they reproduce locally. However, surrounding unmanaged or lightly managed zones act as source populations, continuously supplying new individuals. In South Florida's interconnected landscape, especially along canal networks spanning Palm Beach County, this creates a constant inflow of reinvading animals. Even perfectly executed local eradication efforts are undermined by regional connectivity. Field observations and agency reports consistently reinforce this limitation. The Florida Fish and Wildlife Conservation Commission and University of Florida's IFAS extension have both noted that while localized reductions are achievable, sustained population suppression across large geographic areas has not been demonstrated. The issue is not inefficiency of removal methods, but biological resilience at scale. A system with high reproductive turnover and wide dispersal ability resists static interventions unless applied uniformly across its entire range, which is logistically and financially unrealistic. Environmental variability makes matters more complex. Periodic cold events in Florida can cause mass iguana mortality, with individuals becoming immobilized at low temperatures and suffering die-offs. However, these events are irregular and uneven in impact, often affecting specific regions more than others. Paradoxically, such natural mortality events can temporarily reduce populations, only for a rapid rebound to occur in subsequent warm seasons. This creates a cyclical pattern that can be mistaken for successful control, even though it reflects climatic fluctuation rather than sustained suppression. Economic constraints also limit intervention scalability. While individual removals cost relatively little, scaling operations across entire counties quickly becomes expensive. Coordinated, high-frequency removal across urban and semi-urban zones would require sustained funding, workforce coordination, and public participation. Even in areas with high infestation density, such as canal-heavy suburbs in Miami-Dade County, no program has achieved continuous, landscape-level pressure sufficient to shift long-term population trajectories downward. Scientific studies consistently conclude that culling alone rarely leads to long-term suppression in species with high reproductive capacity and broad habitat tolerance. The issue is not simply numbers removed, but ecological replacement rates. In systems like South Florida, where suitable habitat is continuous and reproduction is rapid, removal becomes a maintenance activity rather than a solution. Populations stabilize at high levels, even under sustained human pressure. There is also a behavioral component that complicates removal. Iguanas in heavily managed areas do not necessarily avoid human environments. Instead, they often exploit structural refuges such as drainage systems, dense vegetation, and canal embankments that are difficult to access. This spatial refuge effect reduces the efficiency of removal operations, allowing a portion of the population to persist undetected even in actively managed zones. By the early 2020s, it became clear that human intervention in Florida's iguana problem functions less like eradication and more like pressure modulation. It can reduce visible densities, temporarily suppress local populations, and mitigate damage in targeted areas. But across the broader landscape, the system remains stable in its invasion state. The balance has not shifted back toward elimination, but where human intervention feels inadequate, nature has its weapons too: predators and natural mortality pressures. When it comes to predation, things are a bit complicated. Adult green iguanas, large, armored, and often positioned high in trees or along vertical seawalls, rarely fall prey in numbers that matter. Instead, the real attrition happens earlier, in a narrow and fragile window between egg deposition and juvenile survival. Raccoons patrol canal edges and wetland margins at night, moving methodically through vegetation and soil transitions where nesting activity is most likely. Female iguanas tend to select loose, sandy substrates for burrowing, often the same disturbed soils created by human landscaping or canal construction. These locations are predictable, and raccoons exploit that predictability. Using olfactory cues, they detect the faint scent of freshly turned soil or organic traces left during egg laying. Once located, the nest is excavated. A single raccoon can destroy an entire clutch, 20 to 70 eggs, in minutes. Field experiments conducted in Florida have demonstrated that when raccoon access to nesting areas is restricted, either through exclusion fencing or localized removal, iguana hatchling survival rates increase sharply. In some monitored plots, recruitment doubled or even tripled within a single breeding season. This establishes raccoons not just as predators, but as regulators of entry into the population. Raccoons also exploit the emergence phase, when hatchlings surface en masse after incubation periods of roughly 90 days. These emergence events are synchronized and brief, often occurring at dawn or dusk. For a predator attuned to timing and location, this becomes a concentrated feeding opportunity. In ecological terms, it is a pulse event, where there is high prey density in a short window, and raccoons are among the few urban-adapted predators capable of consistently exploiting it. Feral cats and free-ranging dogs operate differently, but contribute to the same pressure layer. Unlike raccoons, they do not excavate nests systematically, but they are highly effective at intercepting hatchlings once they emerge. Hatchling iguanas, typically under 20 centimeters in length, disperse rapidly from the nest in search of cover. This movement exposes them to ground-level predators in open or semi-open environments. Cats, in particular, are visual hunters, relying on quick bursts of speed to capture small, moving prey. In suburban environments across Broward County, they represent a consistent mortality factor, especially in areas where natural vegetation has been replaced by lawns and ornamental plantings. that offer limited refuge. Dogs, though less specialized as hunters, contribute through opportunistic predation. In residential zones, encounters between free-ranging dogs and juvenile iguanas often end quickly, with little chance of escape for the reptile. While each individual event may seem minor, the cumulative effect across densely populated neighborhoods becomes significant, particularly during peak hatching periods. Meanwhile, rat snakes and other opportunistic constrictors enter burrows or ambush hatchlings in vegetated areas. In more natural or less disturbed zones, snakes can represent a meaningful predator class, but in highly urbanized landscapes, their role diminishes. Together, these ground-level predators form what ecologists describe as a distributed filter. No single species eliminates large numbers across the entire landscape, but collectively, they remove a substantial proportion of individuals at the earliest stages of life. The effectiveness of this filter, however, is highly variable. In heavily developed urban areas, where predator diversity is reduced and nesting sites are abundant, more hatchlings survive. In semi-natural corridors, where raccoons and other predators are more active, recruitment drops sharply. Above this ground layer, a second tier of predation operates from the air. The most visible aerial hunter in this system is the great horned owl, a predator that operates in near-total silence across South Florida's canal-lined corridors. With a wingspan approaching 1.5 meters and talons capable of exerting crushing force comparable to that of a medium-sized mammal, it is built to take prey far larger than most birds attempt. Its hunting advantage lies not just in strength, but in sensory precision. Asymmetrical ear placement allows it to triangulate sound in darkness with remarkable accuracy, meaning that even slight movements, such as the rustling of leaves or the shifting of claws on bark, can trigger a strike. In suburban edges of Miami-Dade County, these owls often perch above canal banks and tree lines, scanning predictable iguana basking zones as daylight fades. Juvenile iguanas are the most exposed during these transitions between day and night. After spending daylight hours basking to regulate body temperature, they begin to reposition towards safer roosting spots as light levels drop. This movement phase is where vulnerability peaks. The owl does not chase in the conventional sense. It drops, a short glide, a controlled descent, and the strike is delivered with talons extended, often before the prey registers the threat. Observational data from urban wildlife monitoring shows that these attacks are highly efficient when conditions align: low light, minimal obstruction, and a clear line of descent. Adult iguanas, by contrast, occupy a different risk profile. Their size, combined with muscular tails and defensive thrashing, makes them more difficult and energetically costly targets. While there are confirmed instances of adult predation, these tend to occur under specific conditions. Individuals weakened by cold, illness, or displacement from secure perches. The hunting pattern itself is cyclical rather than continuous. Great horned owls establish territories and return to the same perching and hunting zones night after night. In canal-heavy landscapes of Broward County, this creates localized pockets of predation pressure. Within these pockets, juvenile iguana mortality can be noticeably higher, particularly during peak activity periods in warmer months when hatchlings and subadults are more abundant. However, outside these zones, the pressure drops off sharply. The distribution of owls is tied to nesting sites and suitable canopy cover, not to iguana density, which limits their ability to track and suppress prey populations across broader areas. Other raptors contribute, but with more constrained impact. Red-shouldered hawks and similar species are present throughout South Florida, yet their hunting strategies differ. They rely on daylight visibility, striking from perches with short bursts of speed. This limits their effectiveness against iguanas. These lizards are most vulnerable either at night or during transitional periods when these hawks are less active. Smaller owls, while capable hunters, are restricted by size and typically focus on smaller prey items, only occasionally taking very young iguanas. Surveys conducted along canal systems in Palm Beach County consistently categorize this entire avian component as secondary in terms of population impact. Researchers tracking carcass remains, feeding sites, and predator activity patterns find that while raptors do remove iguanas, the frequency is too low and too uneven to influence long-term population trends. In many cases, the presence of avian predation is inferred from indirect evidence, such as scattered remains, feather traces, or isolated camera trap footage, rather than sustained high-frequency events. What makes avian predation intriguing is not its scale, but its precision. Unlike ground predators that target nests or emerging hatchlings in bulk, raptors remove individuals selectively. This introduces variability into mortality rates across different habitats and time periods. In one canal corridor, a resident owl pair may significantly reduce juvenile survival over a season. A few kilometers away, in a similar habitat without that pair, survival rates may be markedly higher. There is also a behavioral dimension to this interaction. Iguanas in areas with consistent raptor presence may alter basking height, timing, or movement patterns, subtly shifting their exposure windows. However, these adaptations are limited by the species' physiological needs. They must bask to regulate body temperature, and they must move between feeding and resting sites. This creates an unavoidable trade-off: energy acquisition versus predation risk. Raptors exploit that trade-off. At the top of the predator hierarchy sits the Florida panther. This beast deserves a detailed mention of its own. By the mid-20th century, the Florida panther had been pushed to the brink.
In the early 80s and 1990s, probably only about 20 to 30 Florida panthers left in the wild.
I mean, that's pretty close to extinct.
Yeah, close as you can get.
Its range had been shattered by development across South Florida, its population collapsing to just 20 to 30 individuals by the early 1990s, and its survival was threatened not only by habitat loss and road mortality, but by severe inbreeding. A turning point came in 1995, when conservationists introduced Texas pumas under the direction of the U.S. Fish and Wildlife Service, restoring genetic diversity and triggering a slow recovery that has since brought numbers up to roughly 120 to 230 individuals. Despite this rebound, the panther's role in controlling iguanas remains limited. As a large carnivore, it primarily hunts high-calorie prey like deer and wild hogs, with iguanas appearing only as occasional, opportunistic prey. The mismatch is both biological and spatial. Panthers roam vast protected territories, while iguanas concentrate in dense urban corridors like Miami-Dade County. Even in overlapping zones near places like the Everglades, encounters are infrequent, making panther predation on iguanas a rare incidental event rather than a meaningful population control force. Still, it is part of the equation. Together, these predators create crucial bottlenecks. Without them, the iguana boom would be virtually unstoppable. But there is something else that's killing the invaders in much greater numbers: environmental and biological constraints on survival. As ectothermic reptiles, iguanas depend entirely on external heat sources to regulate body function. When ambient temperatures drop near or below 10 degrees Celsius, their muscle function slows to the point of near paralysis. In these conditions, they lose the ability to grip branches and often fall from trees.
Iguanas are falling from the trees as a rare cold snap grips the sunshine state, as it's called. The immobilized iguanas were found lying on the grass, the pavements, even in backyards.
A phenomenon widely reported during cold snaps across Miami-Dade County and surrounding regions. These cold events are well documented in Florida wildlife reports, particularly during unusual winter cold fronts that periodically sweep through the state. During such events, iguanas have been observed immobilized on fences, sidewalks, and tree canopies, sometimes appearing lifeless until temperatures rise. These episodes can also result in mass mortality events. Biologically, the same traits that make iguanas vulnerable also make them highly efficient survivors in stable conditions. Their ectothermic physiology means they are tightly bound to environmental heat cycles, which creates predictable behavioral patterns. During daylight hours, especially in warm months, iguanas concentrate in basking zones along canal edges, seawalls, and open vegetation. This predictability is ecologically significant. It creates consistent exposure windows, but also allows the population to exploit energy efficiency. At night, however, reduced temperatures slow their movement, making nocturnal activity limited and sluggish. This is one reason why predators such as the great horned owl can occasionally exploit them. But even this vulnerability is conditional. Habitat disturbance is another factor. Rapid urbanization across South Florida has transformed natural wetlands into fragmented mosaics of canals, residential zones, and engineered landscapes. In theory, habitat disruption can limit survival by reducing food availability and nesting sites. In practice, iguanas have adapted exceptionally well to these altered environments. Seawalls substitute for rocky outcrops, ornamental vegetation replaces native forage, and drainage canals replicate the linear movement corridors found in natural river systems. Ironically, urbanization has expanded its usable habitat. Disease and parasites represent a less visible but still relevant factor. Green iguanas are known carriers of pathogens such as salmonella, but large-scale disease outbreaks within wild Florida populations are poorly documented. Unlike mammals or birds, reptile disease ecology is less studied. Most evidence suggests that while individual mortality from infection occurs, there is no indication of disease acting as a population-regulating force at scale. What emerges from these constraints is a paradox. Iguanas experience high mortality across multiple pathways: temperature stress, predation, environmental disturbance, and occasional disease. But none of these factors operate consistently enough to suppress the population as a whole. This is where reproductive biology becomes decisive. A single female can lay between 20 and 70 eggs per clutch, and in Florida's warm climate, multiple clutches per year are possible. Even with significant juvenile mortality, the sheer volume of reproduction ensures continuous population replacement. This is why natural control has failed to rebalance the system. Historically, South Florida supported a broader and more intact predator community. Over the 20th century, habitat loss, hunting pressure, and urban expansion reduced populations of mid- and large-sized predators. The recovery of species like the Florida panther has been a conservation success, but their numbers remain limited, and their range is concentrated in specific regions rather than distributed across the urbanized landscape where iguanas are most abundant. Current predator densities are therefore structurally mismatched to the scale of the iguana population. They are too low in number, too geographically fragmented, and too behaviorally focused on prey other than adult iguanas. Raccoons may suppress nests locally, and raptors may remove juveniles opportunistically, but breeding adults largely remain unaffected. Studies from Florida-based institutions and wildlife management agencies, including the Florida Fish and Wildlife Conservation Commission, emphasize that predation functions as a partial regulatory mechanism rather than a controlling force. It influences distribution, behavior, and local density fluctuations, but it does not reduce the overall population. This is where scientific intervention comes. Science-based paths toward ecological equilibrium. Agencies like the Florida Fish and Wildlife Conservation Commission emphasize that removing adults alone is ineffective unless reproduction is also disrupted. Female iguanas lay 20 to 70 eggs per clutch, often multiple times per year, creating a rapid population rebound that overwhelms most control efforts. As a result, nest detection and destruction, especially in high-density areas like Miami-Dade County, has emerged as the most effective strategy, targeting entire future generations at once. Alongside this, large-scale, coordinated removal is essential. Localized efforts fail because nearby populations quickly refill cleared areas. Sustained, region-wide culling across interconnected urban corridors, including Broward County, is required to produce any meaningful decline. However, even this must be combined with long-term structural changes. Urban design plays a critical role, as canals, seawalls, and landscaping unintentionally create ideal iguana habitats. Reinforcing infrastructure and shifting toward iguana-resistant vegetation reduces food, nesting, and basking opportunities, gradually making environments less favorable. Predator support adds only a limited impact. Species like the great horned owl contribute to juvenile mortality, but do not significantly affect breeding adults, meaning their role remains supplementary. Meanwhile, experimental approaches such as fertility control and behavioral deterrence are being explored. Alongside advanced monitoring tools like drones and camera systems, to track population trends more precisely. Ultimately, no single solution exists. Effective management requires a layered strategy targeting reproduction, removal, habitat, and behavior simultaneously. Eradication is not feasible. The species is too widespread and resilient. Instead, the goal is to reduce populations to tolerable levels where ecological and infrastructural damage is minimized. What South Florida faces now is not elimination, but long-term control, an ongoing balancing act shaped by sustained pressure and ecological adaptation. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.